The year is 117 AD. The Roman Empire is at its peak. No electricity, no engines, no digital systems. And yet millions of people wake up in cities that feel strangely familiar. Clean water flows into homes, streets follow predictable layouts. Construction projects rise on schedule. Time is measured, standardized, and enforced. Waste is removed. Distances are calculated. Deadlines matter. Fast forward 2,000 years. You wake up, you shower, you check the time, you commute on a road designed to move people efficiently from one place to another. You drink clean water without thinking about where it came from, and almost none of it is new. Because long before silicon chips and steel skyscrapers, the Romans solved problems that modern life still depends on, at a scale that has never really been surpassed. Today, we're counting down 7 pieces of Roman inventions you use every day, without knowing it. Stick with me until the end. The last one doesn't just shape how you live, it shapes how you think. Oh, and don't forget to subscribe. But only if you like this video and you want to see more of this. So are you ready to discover what Roman invention you're actually using right now? Let's get into it. Number 7. Roads that move people, not just cars. When most people think of Roman roads, they picture stone slabs and straight lines. Something primitive, something symbolic, but that misses the point. Roman roads were not built to look impressive. They were built to work. Every major Roman road followed the same underlying logic. First, a carefully surveyed route. Romans favored straight alignments, not because they were careless, but because straight roads reduced travel time, simplified navigation, and made logistics predictable. When terrain forced a deviation, it wasn't random. Gradients were carefully controlled to keep carts, animals, and foot traffic moving efficiently without exhausting them. Then came the structure. Roman roads weren't just stone on dirt. They were layered systems. A foundation of compacted rubble. Above that, progressively finer layers of gravel and sand. On top, tightly fitted paving stones. Each layer distributed weight downward and outward, preventing ruts, cracks, and collapse. This is load distribution, the same principle modern engineers still rely on. Drainage mattered just as much. Roman roads were slightly crowned in the center, allowing rainwater to run off into side ditches. Water didn't pool. It didn't freeze and crack the surface. The road stayed usable in every season. That's why some Roman roads survived centuries of traffic and centuries of neglect. Now fast forward to today. Many modern highways still follow Roman routes. Not out of nostalgia, but necessity. Those paths already solved the hardest problems. Where to cross rivers, how to pass through mountains, how to connect cities efficiently. Asphalt may have replaced stone, but the logic underneath hasn't changed. Standardized widths, predictable curves, controlled slopes, drainage first, surface second. Modern roads feel advanced because they're faster to build. Roman roads were advanced because they were built to last. It's the most obvious example of Roman technology still in use, and the one most people misunderstand the most. They weren't just building roads, they were engineering movement itself. But here's something that will blow your mind. Most Roman roads you see in tourist photos aren't Roman at all. Walk through the countryside in Spain or France, and locals will proudly show you cobblestone paths they swear date back to Caesar. Medieval restoration. Many of those picture-perfect cobbled roads with rounded wheel guards along the edges. Built in the 1700s. The Romans never used those cone-shaped road markers. Those came 16 centuries after Rome fell. So how do you spot a real Roman road? First, look at where it goes. A genuine Roman road avoids valley floors. This sounds counterintuitive. Modern highways often hug rivers because the terrain is flat and easy, but Romans knew something we forgot until recently. Valleys flood. Seasonal rivers change course. Marshland shifts. A road built in a valley might work perfectly for 5 years, then disappear underwater for 3 months every spring. So Roman engineers surveyed routes that stayed above the floodline. They'd rather add distance than risk seasonal disruption. When archaeologists analysed routes in Hispania, they found roads systematically positioned on hillsides and ridges, steering clear of bottoms even when it meant more challenging construction. Second, look for infrastructure that doesn't lie. Stone doesn't pretend. If you see a bridge with a single graceful arch spanning a river, built from precisely fitted voussoirs without mortar, using the exact load transfer principles Vitruvius described, you're looking at Roman engineering. Modern restorations can fake surface paving. They can't fake 2,000-year-old structural physics. Third, check for milestones. Not the decorative roadside markers placed by tourism boards. Real Roman milestones. Cylindrical stone columns, often broken or repurposed into farm walls, inscribed with the emperor's name, the distance to the nearest city, and sometimes the name of the official who built or repaired that section of road. In parts of Portugal and northwest Spain, archaeologists found nests of 10 or 12 milestones clustered together, marking sections where roads were maintained and rebuilt multiple times across centuries. Here's what makes this strange. If you find a genuine milestone, it might not be sitting directly on the road. Roman roads didn't always pass through cities. They passed near them, close enough for access, far enough to avoid congestion. The Roman agricultural writer Columella laid down a principle for placing country estates, not on the road, not far from the road. This same logic applied to cities. Roads provided connectivity without forcing all traffic through urban centres. Modern highway engineers rediscovered this principle in the 1950s when building interstate bypass systems. Turns out the Romans had already worked it out. That's the thing about Roman roads. The longer you study them, the more you realise they weren't just solving the problem of how do we get from A to B. They were solving logistics, geography, maintenance, military deployment, trade efficiency, and urban planning all at once, in a system designed to last forever. Number 6. Pressurized water delivery. Water is the one system modern life assumes will never fail. You turn a handle and it appears. Clean, continuous, pressurized, and almost no one asks how. The Romans did. Roman aqueducts weren't just channels carrying water from point A to point B. They were carefully calculated systems designed to control flow, pressure, and distribution across entire cities. The most important feature wasn't the arches. It was the gradient. Aqueducts descended at a nearly imperceptible slope, sometimes just a few centimeters per kilometer, enough to keep water moving, but slow enough to prevent erosion or structural failure. When terrain dropped too sharply, Romans didn't abandon the route. They used inverted siphons. Water would descend into a valley through sealed pipes, build pressure at the lowest point, and rise again on the opposite side, not because it was pumped, but because gravity and pressure demanded it. The system regulated itself. Once water reached the city, it didn't just spill everywhere. It entered a castellum, a distribution tank that split the flow into regulated channels. From there, pipes carried water to fountains, baths, workshops, and private homes. Flow rates were controlled. Priority users were defined. Excess water flushed sewers and drains. Nothing was accidental. This logic should sound familiar. Modern municipal water systems still operate the same way. Reservoirs are placed at elevation. Gravity provides the pressure. Pumps assist when needed, but they're not the foundation. Distribution networks divide flow, regulate pressure, and prioritize essential services. Electricity makes it easier. It doesn't make it possible. What's striking isn't that the Romans moved water. It's that they treated water as a managed system, not a resource you simply accessed. The Romans built cities where water arrived constantly, predictably, and quietly. So quietly that 2,000 years later, we still expect the same thing, without thinking about who figured it out first. Number 5. Concrete that was built to last. Walk through any modern city and you'll see concrete everywhere. Sidewalks, bridges, buildings. And you'll also see the cracks, the patches, the constant repairs. The Romans saw those same problems and solved them differently. Roman concrete wasn't just a weaker version of what we use today. It was a different material entirely. Instead of relying on Portland cement, Romans mixed lime with volcanic ash, creating a chemical reaction that continued long after the concrete was poured. The result wasn't just hard, it was alive, still reacting, still strengthening over time. For centuries, historians assumed Roman concrete lasted simply because it was thicker, but recent analysis tells a different story. Inside Roman concrete, researchers found lime clasts, small fragments of quicklime that were never fully mixed. At first, this looked like a mistake. Poor craftsmanship, incomplete processing. It wasn't. When cracks formed and water seeped in, those lime clasts reacted. They expanded, filled the fractures, and effectively healed the structure from the inside. The concrete repaired itself, not once, repeatedly. Modern concrete doesn't do that. It's optimized for speed. Pour it fast, cure it quickly, move on. It's strong at first but brittle over time. Once it cracks, the damage spreads. Maintenance becomes permanent. Roman builders had a different priority. They weren't racing quarterly budgets. They were building for generations. Harbours that resisted seawater, vaults that still stand, domes that remain unsupported 2,000 years later. And here's the uncomfortable part. Modern engineers are now trying to recreate Roman concrete, studying it, testing it, asking how ancient builders achieved something we lost along the way, not because it's romantic, but because it works better in the long run. That's why this chapter matters. Progress isn't always a straight line forward. Sometimes it's a loop. Roman concrete reminds us that efficiency and durability are not the same thing, and that the most advanced technology isn't always the newest. It's the one that refuses to fail, quietly. Number 4. Standardized time. Before time was measured, it was felt. The sun rose, the sun set. Work happened when it could. That doesn't work if you're running an empire. The Romans understood this early. Courts needed to open and close at fixed moments. Markets needed predictable hours. Military watches had to change on schedule. Orders had to be given, followed, and enforced at the same time in different places. None of that is possible without shared time. So the Romans built it. They divided the day into 12 daylight hours and 12 night hours. Those hours weren't fixed in length. They expanded in summer and shrank in winter, but they were standardized within the system. Everyone agreed on when the first hour began, when the sixth hour marked midday, and when the working day ended. To enforce this, Romans used technology. Sundials stood in public spaces, calibrated to local latitude. Water clocks, clepsydra, measured time when the sun wasn't visible, indoors or at night. In courts, water clocks even regulated how long someone was allowed to speak. When the water ran out, so did your argument. Time became something external, something shared, something that could be enforced. This was a quiet revolution. Once time was standardized, behavior followed. Shops opened together. Labor was organized into shifts. Religious rituals, civic duties, and military operations synced to the same temporal framework. People didn't just live in cities anymore. They lived on schedules. That structure never disappeared. Modern hours no longer stretch and shrink with the seasons, but the discipline is the same. Workdays start at fixed times. Appointments are measured in minutes. Deadlines rule entire industries. You don't negotiate with time, you obey it. We often think clocks change society. In reality, society demanded clocks. That's why this chapter marks a shift. Roman roads shaped movement. Water systems shaped survival. Concrete shaped permanence. But standardized time shaped behavior. The Romans didn't just measure hours, they taught millions of people to live by them. And once that idea took hold, there was no going back. Number 3. Cranes that built the impossible. When people imagine Roman construction, they picture brute force. Hundreds of laborers hauling stones with ropes. Progress measured in exhaustion. That image is wrong. The Romans didn't move heavy stone by strength alone. They engineered machines that multiplied human effort to a scale that still surprises modern engineers. Roman cranes were not simple hoists. They were precision lifting systems built around pulleys, gearing, and human-powered tread wheels. One worker walking inside a large wooden wheel could generate enough force to lift blocks weighing several tons. Not by pulling harder, but by letting physics do the work. The key was mechanical advantage. By combining compound pulley systems with tread wheels, Roman cranes redistributed force across distance and time. Lifting was slow, controlled, and repeatable. Stones could be raised vertically, swung into position, and set with accuracy measured in centimeters. We know this wasn't theoretical. Reliefs like the Hetairai tomb show cranes actively lifting architectural blocks. Tool marks on stone match controlled hoisting, not dragging. And experimental reconstructions based on Roman designs confirm what the evidence suggests. Small crews could safely lift weights that would otherwise require dozens of workers. This changed everything. Cranes allowed Romans to build upward instead of outward. Multi-story apartment blocks, massive vaulted ceilings, aqueduct arcades rising stories above the ground. Construction no longer depended on terrain or raw manpower. It depended on calculation. Modern tower cranes operate on the same principles: gears, pulleys, load distribution, and balance. Electricity replaced walking wheels, but the logic is unchanged. You're not watching brute force at work. You're watching Roman physics with a modern power source. Roads move people. Water sustains cities. Concrete preserves structures. Cranes made scale possible. They didn't just lift stone. They lifted architecture beyond what the human body alone could ever achieve. Number 2. Measurement and surveying. Before anything could be built, it had to be measured. And before it could be measured, it had to be agreed upon. The Romans understood that empires don't collapse from lack of ambition. They collapse from lack of precision. Roman surveyors weren't guessers. They were specialists trained to impose geometry onto the landscape. Using instruments like the groma, they established perfect right angles. Roads ran straight not by intuition, but by alignment. City grids weren't symbolic, they were calculated. Property boundaries, military camps, aqueduct routes, and building foundations all began with measurement. This mattered more than it sounds. A road that drifts off course by a single degree will miss its destination by kilometers. An aqueduct with an incorrect gradient will either stagnate or tear itself apart. A city without consistent measurements can't expand without chaos. Roman surveying solved these problems before the first stone was laid. They didn't rely on maps alone. Surveyors worked directly in the field, translating abstract geometry into physical reality. They leveled terrain, measured elevation changes, and calculated distances with tools that looked simple, but produced results precise enough to support massive infrastructure across continents. The groma was brilliantly basic, a wooden cross mounted on a pole with plumb bobs hanging from each arm. When all 4 bobs hung perfectly vertical, the surveyor knew the cross was level and could sight along its arms to establish perfect perpendicular lines. From those lines, entire city blocks could be laid out with geometric precision. For leveling over long distances, Romans used the chorobates, a long wooden beam, sometimes 6 meters across, with a water-filled channel carved into the top. When the water sat level in the channel, the beam was level, simple, accurate, repeatable. And for angles and slope calculations, the dioptra, a rotating sighting tube mounted on a calibrated base, allowing surveyors to measure angles with remarkable accuracy. The same geometric principles that guide modern theodolites. Modern technology feels different. Laser levels, GPS, digital mapping. But underneath it all, the process hasn't changed. Straight lines are still straight lines. Right angles still matter. Gravity still defines slope. Modern instruments don't replace Roman geometry, they refine it. What's easy to miss is how deeply this shapes daily life. Your city block aligns the way it does because someone measured it. Your property line exists because someone defined it. Your commute follows a predictable path because someone planned it. Measurement is invisible, but it governs everything. Surveying doesn't impress the eye, it impresses reality. Without it, roads fail, water stops, buildings collapse. Roman measurement wasn't about numbers, it was about trust. The trust that if something was built once, it could be built again, somewhere else, the same way. That's how systems scale. Number 1. The system itself. The Romans didn't change the world by inventing a single tool. They changed it by inventing a way of thinking. Every technology you've seen so far, roads, water systems, concrete, cranes, surveying, timekeeping, only works if it can be repeated. In different cities, by different people, across generations. That was the Roman breakthrough. They standardized everything. Measurements were consistent. Procedures were written down. Construction methods followed known rules. Calendars synchronized civic life. Legal codes defined responsibility. Engineering wasn't improvisation, it was process. If something worked once, it could work again, anywhere in the empire. This is why Rome scaled. A road in Gaul followed the same logic as a road in Syria. An aqueduct in Spain functioned like one in North Africa. A crane in Rome lifted stone the same way one did in Britain. Builders didn't need reinvention, they needed instruction. That mindset is everywhere today. Modern institutions run on procedures, standards, manuals, and protocols. Cities follow building codes. Engineers rely on specifications. Governments operate on calendars, deadlines, and documentation. Nothing works unless everyone agrees on how things are done. We often credit modern technology for this order, but technology only accelerates it. The structure came first. The Romans understood something we tend to forget. Tools don't create systems. Systems create tools. Once you design a framework where knowledge is preserved, shared, and enforced, progress becomes cumulative. Mistakes don't reset you to zero. Success compounds. That's why Roman influence didn't vanish when the empire fell. The system outlived the state. You don't just use Roman technology when you drive on a road or turn on a faucet. You use it when you follow a schedule, when you trust a measurement, when you expect consistency from a system larger than yourself. The Romans didn't build the modern world by accident. They built it by design. And 2,000 years later, we're still living inside that design, often without realizing it was ever drawn at all. Thanks for watching. I'll see you in the next one.